Good morning, everyone. Last time we met, we ended up talking about how to create our own functions. So this time we're actually going to go through an example of how to write a function that's biologically useful. So this is actually a function that I do use here and there for my actual work. So I want to give a little bit of background about what a FASTA file is. So a FASTA file usually has two components. The first is the header line, so it usually starts with this kind of like caret looking symbol, and it has a description of the sequence. So a lot of times biologically, this could include like the barcode of the cell that it came from, the barcode of the sample that it came from, information that might be just helpful about the sequence itself. And then it will have some sequence information. So these are just the amino acids. And then the next sequence that begins, you have another caret with sequence. So this is a really important file format in bioinformatics, particularly because this is how genomes are stored. So for the human genome, for instance, you would see this would say like CHR1, like chromosome 1, and then you have the entire sequence of chromosome 1. And then you have chromosome 2, the entire sequence of chromosome 2. So being able to kind of iterate through and work with FASTA files is really helpful. So we're going to start by kind of creating a fake FASTA file in just line format. So I'm going to resend this link, and I want you all to open up to this line, unless you want to just make up nucleotide sequences, that's fine. But we're going to go ahead and add these in to a file. So go ahead and copy this, navigate to your Python focus group, and we can make something called like function.py or like FASTA reader.py, whatever you want to call it. And we can go ahead and open this up. So we can see GitHub, Python focus group. Okay, so there I have my FASTA reader.py open. So remember, we're copying just the part right now that says lines, all this sequence information. So what we should see here is a list. So this is a list because it has square brackets, and each component is separated as its own line. So we have the quotation marks separated by comma, and we have the sequence header, sequence header, sequence header, sequence. And this is actual information that I worked with. So Camille's not here right now, but this is from working with Camille single cell data. This is actually the FASTA file sequences that I was using and iterating through for some of the stuff I was doing. So let's say we actually want to learn to start reading in FASTA files. Last session, we learned about how we can go ahead and create our function. So we're going to say create function to read in FASTA file. And here we'll use that def, like the define function, and say read FASTA. That's going to be what we call it. And we need some kind of argument here. So the argument that we want to input is the FASTA information. For now, since we're just working with a bunch of lines, we can just say lines. And if we want to create a function that's able to associate the name of the sequence and the sequence together, we need to start taking into consideration what are the different components of the sequence and how can we differentiate them. So the two main components are the name of the sequence and the contents of the sequence. So in order to get the name, we can just initialize a variable for now. So we can say name equals none. This will just initialize it. And then for sequences, one thing we should consider is that notice that some sequences have multiple lines to them. Not all of them have all the sequence on one line. That's actually pretty typical for a FASTA file. So we'll just put sequences and we'll make a list to store any of the sequences in for now. So Now that we have initialized our variables, we can start getting through the logic of actually reading in the information. So one thing that we can do, since these are just lines in a list, is use a for loop. So we can say iterate through sequence lines. So since we have the for loop ability, we can say for line and lines. And now we can think, like, is there anything that we should be doing to these lines that might be helpful? And the answer is yes. And the reason I say that is because there are times where there's white spaces, either at the beginning or at the end or something. It's just a possibility that not everything is perfectly formatted. And that's actually kind of common, so it's something you want to take into consideration. When you're coding, there's a lot of times that you have to think, like, how many different ways can my code break? And you have to account for that in the code. So we can say strip any white space or line break characters at the end of the line. And this will prevent any issues from happening. So we can say line, which overrides this variable. So we'll say line equals line.rstrip. So remember, rstrip strips to the right of the string. So if there's like a line break character, which if you're using Windows, there is actually a character here that's invisible that signifies a line break. So this is kind of important depending on how you created your FASTA or where you're getting it from. So now, for simplicity's sake, let's just see where we're at. So we'll print the line. And remember that all we have done here is define the function. We haven't actually run anything. So here we will run the function. So read FASTA, and we'll put lines because lines is our object. And we can do Python 3 FASTA reader.py. So here now inside the for loop, we're printing every single line. So this is good. This is exactly what a FASTA file will look like without all the weird formatting. So now we can start assigning different components. So we've printed the line. We can get rid of that because that was just a sanity check. Now that we've stripped the white space, how do we go about assigning the name versus the sequence? Well, one thing that we know is that anything that starts with this kind of carrot-looking symbol, if anyone knows what that is, a greater than sign, I guess. But the symbol that denotes the line or the sequence header name. So maybe we can do a conditional here. So we can say if, or we'll be good and add comments. So we'll say assign sequence headers as name. So we can say if the line, and then there's a starts with function. So starts with, and then that greater than sign. Then what we can do is say name. So name is initialized as none, but we can now assign it to something because we're saying we will assign it if the line starts with this. So we'll say the line is equal to name now if the line starts with this. So now, just for sanity, we'll print the name and we'll see how that goes. So we're getting there. So we see now in terms of the function name or the sequence name, we have the constructs and the information, but we still see an issue. We see that there's this piece, and that's not technically part of the name. That's just there so that people can write code that allows them to parse out the different components. So now we're faced with the situation of how do we get rid of this piece here in the lines? And one of the things that I've kind of tried to stress over the course of this Python focus group is there are so many different ways that you can do something. So you can either strip the first character of the name, you can use the replace function and just replace this with nothing. So it really depends how you want to go about it. But since we know that this is always the first character, I'm going to just use the let's strip the first character off function. So we'll say name equals line, or instead of line there, we can say, let's strip the first part of this. So this goes back to when we were learning about string operations, where you can do indexing. So this essentially means everything from the first, like position 1 onwards. So that takes off the first character because remember the first character, the indexing is 0. So this is saying index 1 onward. So now if we print this, it has effectively removed these pieces. So at this point, what we've done is we've read in our lines, we've been able to initiate our names and sequences, and we've extracted the names of the sequences. So what else can we do now to find the sequences? 1 second, I'm gonna drink some water. Okay, so what we can do is say if the line starts with this, the alternative is it doesn't start with that symbol and makes it a sequence. So this is where we can use an else and say else. And then since we initiated sequences as a list, we can say, you know what, let's append. So we'll use that append function and append the line to sequences. And then we'll print sequences. So what we're seeing here is we do have the construct and the sequences associated with it, but it's a little funky. So like we see there's a problem here. It has the first sequence, the second sequence, but now it's just adding sequence to every single thing. So the SCP construct sequence, because we didn't restart the variable, it's just saved regardless of what's being read in. It's not associating the actual sequence to the construct itself. It's just saying, here's your full list of sequences. And that's not really what we want. So what we're going to have to do is figure out a way where we can fix that. And because Python is read line by line, we can reset sequences somewhere else. So every time we assign name, maybe we can reset the sequences. So we can say reset sequences. So we'll say seeks equals, and then just give it the empty list again. So this means that every single time we are encountering a new sequence name, it is resetting our sequences and then appending the sequences accordingly. So now this is working better. So we do see, for example, the CDKL5 guide RNA. It's just the guide RNA belonging to that one, just this guide RNA, just this guide RNA, but we still have another issue here. So the issue that we're facing here now is we see that anything that has multiple lines now just has multiple entries in a list. And this is not really a format that we can use if we're trying to get our sequences back to work with. So we have to figure that out. So now we can say, you know what? One thing I want to touch on really quick is indentation. So because all of this is happening on a line-by-line basis, we're now moving to functionality that is after all of this has happened. So now we can unindent this. So we can say format proper output, and this will help format our sequences. So since sequences is a list, we can use a join function. And what that does is basically combine everything in a list. And you can use a separator for this, but if you just do no separator, it just combines it. So this part is a little tricky, but we can say if name. And what that means is currently we have set name equal to none. So if there's nothing being read in, none of this stuff will execute because this will only execute if name exists or basically if name is not none. That's, again, that's kind of a tricky, weird way to think about things, but if name gets assigned, then we can go ahead and move on with this. So we say if name seek equals, and then we're not going to join it with anything. We're just going to put nothing in the middle, and then a dot join, and then we'll join sequences. And we'll call this seek because now it's just a singular sequence as opposed to sequences. So now we can say, instead of printing our name and seek up here, let's print it here. So print name, print seek. And this will run our function. This is the classic, it was indented wrong. So name and seek gets overwritten every time something happens. So we need to actually like indent it properly if we want to see that. So let's do seek, and then we'll just keep print name here for now. Okay, well, this is a good example of a problem that we're going to demonstrate next, which is we need to figure out a way to return our stuff in a way that we can use it. So right now we've just formatted stuff, but we need to actually be able to return it. And we want to associate it with each other. So notice like we have this SCP construct here and the guides, but we're only getting one thing at a time because we're iterating through it. Like every time we're reaching the end of the loop, those variables are being overwritten and we're only getting one thing. So now we need to figure out a way to store those things that we've created and parsed out in a way that we can use it. We can do that with a dictionary because a dictionary associates two values with each other. So if we want the name and the sequence always associated, a dictionary makes sense here. So instead of printing name and sequence, what we'll actually do is initialize a dictionary up here. So we'll say initialize dictionary, and this will stay empty until we populate it. So we can say FASTA contents equals, and then use those little curly brackets. So now, if we want to actually add to this, we can start adding our stuff to the dictionary. So we've already created name. So we've said if name, that means that this sequence should be associated with this name now in every iteration of this. So what we'll do is say FASTA contents, and we're just adding to a dictionary. So remember, when you add to a dictionary, you use the key value addition. So you say the name, and the name is equal to the sequence. So now what we can do here is print FASTA contents and see if our association worked. So I'm going to clear this. So we're still running into an issue. And one thing we notice is there's an indentation problem. So the indentation of the conditional, where it's indented outside of here, is now just saving name instead of in the line-by-line iteration. So let me try to explain this a little better. We're iterating line by line. So after we've iterated line by line, the last thing that gets saved is equal to name. So then when we unindent, it's only using the last thing. So what we need to do is say, okay, we need to indent this now. We need to indent this and put it in the for line in lines so that we're saving every iteration when we add to the dictionary. So we indent this now. And this seems to be working. So we have SCP construct with the colon and then all of the sequence. We have CDKL5 guide RNA with the sequence. Another CDKL5 guide RNA with the sequence. So this is all sequential, but it's working. So now we want to run this, but The whole purpose of this is that we wanted to actually use the stuff that we have saved. So we want to be able to use the name of the sequence and we want to use the sequence. So maybe we can say something like for name and seek in read FASTA.lines items, because remember that this is outputting a dictionary. So we have to put the dot items and assign two different things here. So we won't print, but we will say print name sequence. And this yells at us. It says none type object has no attribute items. Now, Nick asked a really great question last time, specifically on the idea or poking at the idea of why we need to assign something to with return versus just setting something equal or printing. I think they had asked about why stuff was still printing out. So this is a really good example. We create all of this. We have created FASTA contents, we have populated it, but we have not told our function to actually return anything to us. So when we're running it, the read FASTA.lines, it says that the output is none type because we're not actually returning anything. So this is where we need to use that return function we talked about last time. So this should be indented at the outermost layer of the function. So we'll say, return FASTA contents. So now we have initialized our FASTA contents dictionary, initialized our name and seek variables, assigned our name, assigned our sequences, and formatted everything properly, and now we're returning it. So now if we do this, it works. So again, like last time we were talking about how if you need to get something from a function, you need to use return. So now that we have used return, we're able to use the output of this function. So since it's a dictionary, we can use the dot items and say name or key value, or in our case, name sequence. So we made it pretty far now. We've effectively been able to say we have a FASTA file sequence, we have our headers, we've parsed everything out, we've gotten pretty far. But now I pose another question to you, which is how frequently do you copy and paste your FASTA file into the top of a script and format it like a list? The answer is never. You are never going to do that. So now that we've built the basic functionality, what we're going to do is now shift to doing a file read-in. So instead of reading in lines within the same script, we're going to read in an actual file. So here I want you to create something called sequences.fasta. And once you have created sequences.fasta, I'm going to resend this link in case anyone needs it, or in case anyone new has joined. But go down to the part where it says reading file inputs, and it's perfectly formatted for a FASTA file. I want you to copy all of this sequence and put that in your sequences FASTA file. So we have sequences.fasta. So here's my FASTA file. I will just copy and paste that straight in, save it, and you don't need to do anything else. You can just save it and close it, and you're good. So because we are now going to shift to reading in a file, we can delete our list because our list does not mean anything anymore. So we can also say, instead of reading in lines, let's read in a FASTA file. So I'm actually going to give it a moment before we shift forward to the file read-in and pause and see, did anyone have any questions about just the functionality of how we did everything and kind of the logic we ran through for this?
I missed it really quick. When you in the one that was sequences.fasta, was that just did you copy over the lines segment with the FAFSA sequences?
Yeah, so I just copied over this into sequences.fasta. So if I open my sequences, I accidentally right-clicked to move to OneDrive. I did not want to do that. So I guess I'm recreating it. So one thing you can do, I suppose, is say sequences.fasta, and then you can just copy it straight in. So this is a use case you can use Nano for because like it's just open, copy, paste, and we're not touching it again. So you can use Nano
Oh,
for this. Um, so copy, paste, and then save that. And if you want to be careful, you can say head and just confirm that you saved your sequence information into it.
thank you.
Yeah, no problem. So are there any other questions before we jump into the file read-in? All right. So we have deleted our lines list and said FASTA file. So now what we're going to do is actually format this. So currently we have 4 line and lines, but lines doesn't really exist anymore. So I'm going to just kind of create some space here and give myself some room to work. You don't have to, but for some reason my brain, it just makes sense in my head to have that space there because I'm like, okay, this is the thing that requires my attention that I'm working on right now. And luckily Python doesn't really care if there's a bunch of spaces. So now we have to figure out how do we open a FASTA file. So we'll say open the FASTA file. So this is a good example of, let's say there's a functionality we don't know. So we'll go to Google or whatever search engine you want and say how to open file Python. So we see there's an open function, but it says the best practice is using with. So you say with open, and then you read in the file. So that's basically what we're going to do. We're going to say with open. So we'll say with open, and then we give it the name of the file. Since we want it to be reading in a variable, we just pass it the variable name. So FASTA file. And then there is an argument here. So notice that when it says open name and then mode. So mode refers to like read, write, like literally kind of like the file permissions. Like, do you want to read? Do you want to write? We just need to read this, so we're just gonna say R. So like, we just need you to read it. That's fine. And another standard practice is that after you say with open, you give it an as and then another variable. So what we're doing is saying we're opening this function, reading it, or opening this file, reading its contents, and saving its file contents in a variable called f. So this is really bizarre, but this is just how you open files in Python. And again, we can dive more deeply into this. So opening a file in Python. So they have all sorts of resources you can use. So for example, this is like an example file, and here you can just open and then print. So you can say f equals open. So this is essentially the same functionality we have, except we said with open and then as f instead of saying f equals open. Again, there's multiple ways to do things in Python. Using the with statement is generally considered better. So this is like the standard field, like the field standard when it comes to opening files. You say with open as f. Some people say FP, some people say F. It doesn't really matter. Usually when you see with open something as F, you're opening a file that is stored somewhere. And sometimes you can close files. This is unnecessary. We don't really need to worry about that right now. But this is the functionality we need. So if you're in a situation where you're trying to create a custom function and you're like, yeah, I need to do this functionality, how do I do it? Just look it up. Google is a good friend of yours. There's all sorts of resources online that will walk you through exactly what you need. And there's even AI at this point, which will make sense. So like, let's say I want to use duck.ai. This is just a model that doesn't save your stuff after you close your browser, and it doesn't train models. So it's kind of private, So let's say I wanted to say I have a file called sequences.fasta. How do I open the file in a Python script? Yeah, so it can give you a version here where it says here's file path and then with open file path R as F. So this is essentially exactly what we have. Down to even the functionality that we're going to have downstream, because what we're doing in our function is the best practices. So moving forward, I'm just trying to demonstrate like you're going to hit situations where you don't know how to do everything, and that's fine. You can always look it up. So we open our file, and now we get to iterate through the lines. So we'll say for line in F, what we realize now is just this functionality here. So instead of doing that, we can just indent all of this under the with open. And here, instead of for line in lines, we can just put for line in F. So now we're still working with the line variable. Everything still seems to be working fine. So we're all right. This is doing, I think, what it should be doing. So I'm going to format it a little nicer now. So now if we look, we're reading a FASTA file. We open the FASTA file, iterate through and assign all our variables, and then return the contents of the file. So now when we want to run that, instead of read FASTA lines, we give it the name of the file. Now, this is where it becomes very important to consider where your file is. Since we have created it in the same directory as our script, we can just give it the file name. If it was somewhere else, we have to give it the file path. So here we'll say sequences.fasta. Ah, my bad. There we go. So now we have read in, like, notice this doesn't have the data anymore in it. Like, it doesn't have this information stored anywhere in the script. It's reading it in from somewhere else. And I want to quickly note, this is really good. Generally, when you are writing some sort of script or code, you want to write it in a way that you can reuse it in the future. You want to write it in a way where you're not going to end up being like, oh, let me delete, like, let me just create a copy of this script, delete this, and redo a bunch of this. The more flexibility you have in your scripts to read stuff in, the better it generally is. So now I'm going to add in some more complicated stuff. So here we have sequences.fasta, but FASTA files have all sorts of formats. So you can say, or file extension names. So you can say sequences.fa. You can have sequences.fasta. You can have sequences.fa.gz, sequences.fasta.gz. All of these are completely valid file extensions for FASTA files. Now, the biggest ones I want to point out are these two here. So FA versus FASTA doesn't really make a difference functionally with what we're creating in our function. This .gz part does. So remember that I said earlier in the session, typically when we're reading in FASTA files, we're working with massive amounts of data, like the whole human genome, for instance. And one of the ways that people store data is by gzipping it. And gzipping is a form of compression. So this .gz means that it has been gzipped. So we can try to add a functionality that addresses that. Because let's say we gzip our sequences.fasta file. Now when we look at it, we have sequences.fasta.gz. It's been gzipped. So now if we do .gzip, it is not going to work anymore. It doesn't know it, or not gzip, gz. It's not going to work anymore. Because once you gzip something, it compresses it in a way that it's not readable anymore. So remember when we did head sequences.fasta, we could just look at it. Now if we do head sequences.fasta.gz, it gives us binary. So it basically compresses it in a way that it can keep the information computer readable, but not human readable. And by translating it to only being computer readable, we can no longer understand it, and our code does not work with it. So let's say that that's the case. There's two options we have here. We can either just say, I'm only going to accept like G unzipped files, and that's what my script does. And then you can force your people to run G unzip so that it's only sequences.fasta. That's one way you can go about it. The other is you can just try to make it work. Like you can add a functionality in your script that handles both gzipped and unzipped files. And that's the better practice way to do it because you generally want to account for different ways that things can happen. So let's go ahead and test this with a gzipped version of our file. So we'll say gzip sequences.fasta. So make sure you have sequences.fasta.gz. And then once you have this, now we need to return to our script and try to see what places we can actually incorporate this logic. So here we are reading in our FASTA file. We have our FASTA contents, but the first time we open it is right here. So we can probably add in some functionality here and say a conditional. So it might be zipped, it might not be. So we can handle that. So we can say unzip the file if needed. So we'll say if FASTA file, and then we see that the big difference here is it ends with a .gz. So we can say if FASTA file dot ends with gz, then we unzip it. So this is where you can say, I don't know this functionality. So we can say how to gunzip file in Python script. And it will give you different ways that you can go about using it. sutil or shutil is one way, zip file is another way. I just use the gzip module itself because that makes sense to me. But there, again, there's multiple ways you can go about this. I'm going to import gzip. So at the very top of your script, it's generally custom that when you're writing a script like this, you have your modules imported at the very top. So here you want your modules imported at the very top because that tells whatever person is using your stuff what they need to install. In our case, we're lucky because gzip is just a native Python module. So if you have Python installed, you have access to it. So in the gzip utility, you can say fhandle, which means we're like handling f, gzip.open FASTA file. So the gzip, we get that functionality by importing this gzip module. So what it does is it gives us the gzip and gunzip functionality within our Python script. So now we say gzip open FASTA file. I forget what RT is. R is read. I don't remember T, but I do remember when I had looked up how to do this, it generally recommends you use RT. So I'm just doing what the internet says is kosher here. And then we have the if now else statement. So it's either zipped or unzipped. So now we can just say else fhandle equals open FASTA file RT. So if it's gzipped, we open it with the gzip function. If not, we just open it. So the problem here, oh, I see something in the chat. Read text is what Google says. Okay. So yeah, there's like 9,000,001 ways to do this. So this is one just the one I'm familiar with, so I'm gonna go with it so that I can teach it. But whatever works for you is also totally fine. Oh, I see. Read RT is read text. That makes sense. I thought T was like some sort of functionality. Read text. Okay, good to know. So RT is read text. Um, So here the open the FASTA file. So we've already used the open function and we've assigned it to fhandle. So instead of opening the file again, which doesn't make sense, we will just use the fhandle that we've already assigned. So we'll just say instead of all this, with fhandle. So this means that if it is gzipped, it will open the file with the gzip functionality. Otherwise, it will just open the file and read the text. Thank you, Julian. It will read the text. And now we're opening the file and running the same functionality that we already had. So now if we run Python 3, FASTA reader. Oh, I forgot to replace this. So here I say with fhandle, but then I still kept f. So we got to replace that with fhandle. There we go. Now we have our functionality preserved. And if we look, we see that our sequences file is gzipped. So we can either gzip or ungzip it, and it will work either way. So now if we say g unzip sequences.fasta.gz, we just have sequences.fasta. This is kind of a foreshadowing one of our future sessions, but notice here that now if we've changed sequences.fasta to gz, we have to open the script and change the script. We're going to learn soon about a way that we will not have to touch the script in any capacity to deal with this. But we're going to remove that gz and just run it again, and we see that it gives us the same output. So basically, I'm now going to transition to giving you some more biological insights here. We finished our function. This function is an actual function that in its finalized form you can use for all sorts of things. Like this is the read in the file and iterate through and it gives you the name of the sequences. So I've listed a bunch of different examples here on what you can do with this function. And this is actually a function I have used and learned how to write years ago and have used in many cases since. So you can create consensus sequences, extract subsequences. So let's say that one functionality of this was when I was working with Nick's data, the single cell data, and I was trying to count guide RNAs. So I went into the FASTA file or the BAM file that was generated and read in the FASTA sequences of all the guide sequences and then read through and searched for those sequences in the BAM file. But that required me to be able to read in the FASTA sequences and have the association of the name and guide, or the guide and sequence. So there's all sorts of different functionalities that you can use this for. But more broadly, the reason I wanted this to be a session is, and the reason that I kind of just hard coded some of the mistakes into it, like if you're confused on any of the logic, I did code the issues that we ran into sequentially. So like every single time we are like, oh, there's this issue. It should be noted in here so you can follow along the logic if you're confused about anything. But I wanted to kind of demonstrate like this is what it looks like to code. You code something and you're like, "Oh, well, what about this case that I need to account for? Let me change this up. Oh, I indented this wrong, so my result's not what I was expecting it to be. Oh, I forgot to return my results. Let me return my results." So it really just is a lot of back and forth. Like it's a lot of let me build up this, let me initialize a variable here, let me see if I can populate it, let me change the way that I did this. That's pretty normal. That's a big part of what it looks like when you're writing a script. So the main points I wanted to demonstrate was how to choose a data task or a data type. So we spent a long time in this course talking about the different data types. And here we used a dictionary, we used a string, we used a list, and we used operations related to all of those different data types. By having a dictionary, we were able to associate the name and the sequence properly and save that information. By having string here, we were able to use string operations to isolate the name of the sequence. By using a list, we were able to handle sequences that had multiple lines worth of sequence. So you need to really understand the different data types in order to be able to choose what you're doing within your script. The big highlight is there's multiple ways to accomplish the same goal. So even, for example, here, instead of line 1 onward, I could have said something like line dot replace this with nothing, and that would have worked just as well. That would have given us the same output. So another example is the gzip. Like we used import gzip, but there's other functions you could use, like zip file, for example, that we looked up. The other thing is the print function. So notice every time we did something, I was like, I want to print it. I want to see what am I outputting. And that's a large part of how I was able to troubleshoot. I'm like, hey, why am I printing this but only getting the last guide RNA? I was expecting all of them. So being able to print and understand the output you're looking for and comparing it to the output you're getting is going to be really helpful when you're trying to draft things. Troubleshooting, finding bugs, those are some of the biggest parts of coding in any capacity. Like 90% of your job is spent going, what did I do wrong and how do I fix it? So it sounds unfortunate and kind of negative, but you get a nice dopamine boost when it finally gives you the output you want, so it's all worth it. We learn how to read in data from files. So yeah, that with open, now I know what RT stands for, which is great. It's just read versus read text. I think there's also W, so if you want to write and like edit the file, you can also do that. If there's modules, like we could have written an entire functionality from scratch on how to g-unzip something. That is wildly unnecessary because somebody has already done that and we can use that work that they have created. So there's no need to reinvent the wheel. There are ways that like other people have already coded these things. So if you're like, hey, how do I do this function? You can always look up if it exists, and chances are it probably does. And then the most important part is just how to sequentially build up complexity. So you look at something like this that I wrote the other day, and you have all this stuff going on here with multiple functions and all sorts of nonsense happening. But how do you get to that point? It's just sequential. Anytime you're writing something, like this would have looked completely overwhelming if we started with saying, like, yep, here's the function, but we wrote it from scratch, and now we have this fully functional item we can use. So, thinking about it like this, if you were to use this function in something, you could just copy and paste this into your script and then do whatever other functionality you need. And that is often how I operate. I'll be like, oh, I have like I have a GitHub repository called personal where I literally just make it private and stick any functions that I'm like, this seems like I could reuse it one day. And I think down to the point that I like probably saved stuff that I've done for Julian like years ago before I even joined the lab. Like anytime I do something that's useful or that I think I could use again, I save it here. Yeah, like Alias or Julia. This was in 2023. And I'm like, well, there was this functionality that I wrote where I'm like, okay, I have argparse and I'm like trying to create a pattern and like rename stuff. I can reuse this logic somewhere else. And I think I had actually. I remember at some point being like, okay, if I want to handle sequence names and lanes and things, like I can reuse this functionality to rename it into this. Like the underscore one versus two dot fastq dot gz. So keeping your code in a way that makes sense and keeping your code organized is really important. So now, if you need this, you can just copy and paste this and put it in another script. So you're not writing something like this completely from scratch. You have pieces of those that you can copy and paste or read in from other scripts that you've written. And that's kind of a big point I want to stress just because I feel like it's really overwhelming to be like, where do I start? Like I have a file and I want to accomplish this goal. Where do I begin? Like the key part is just anywhere. Like write something down. Be like, well, I know I need to read in a FASTA file. So start. Like write a function. Be like, let me write a function that reads in a FASTA file. Let me add information into it. Oh, well, what if it's gzip? Let me edit it to account for that. So really, like you're not just going to write from beginning to end knowing everything that you're doing. And that's just what I wanted to demonstrate. There was a lot of back and forth, jumping through the script, editing things as needed, and that's really typical. So hopefully that makes sense. I know it can be a little confusing, especially with the back and forth. So I do recommend if you're a little confused, like walk through the logic again. Um, I think I even have like the oops written out. Like we have an obvious problem here. So like I've tried to incorporate the logic into the lesson plan so you can see and kind of mess around with it yourself too. So with that said, are there any questions before we end?
I was wondering, I was a little confused on the if name segment. Yeah, right there.
Mhm.
I guess just what, I guess that like kind of chunk what exactly it's doing, but specifically the if name. I think I might have missed the logic there.
Yeah, so if name, the logic here is that if the name exists, because we initialized it as none, this kind of just addresses a situation of like our names are not formally or properly formatted in our script. So let's say we have a FASTA file. Um, let's say head sequences dot FASTA. So let's say we formatted our FASTA file, but we forgot to put carets in the FASTA file, or it's not formatted properly. Then when we go through the conditional of if the line starts with name, when we go through this conditional that assigns the name, this means our file is properly formatted. Otherwise, it's not going to assign name. And if name does not exist and it's still just none, which is what we assigned it at the beginning of the script, it's going to error out and be like, we can't read the data. So it's going to prevent it from making kind of mistakes. Though I think you can just do this. Let me see. That's more of a preventative measure, but I think if you just got rid of that and just did this, it would also work.
That makes sense. Okay, thank you.
Here, we'll try it. Let me make sure I am doing this correctly. Yeah, so I think this will still work. Yeah, so it still works. So you don't really strictly need that. That's similar to how you don't strictly need the gzip portion of the script. It's just one of the better practice things. So if we do the if name, then this means we had to have gone through this process of the script before getting to this part. And if something went wrong anywhere above here, then this will crash out before assigning incorrect information. So it's more preventative than anything.
Okay, thank you so much.
Yeah, no problem. All right. We have lab meeting in 5 minutes, so I guess I'll see you all in 5 minutes in another room.